Hi, my name is Luka Mustafa and I'm the CEO of IRNAS, an advanced applied innovation lab based here in Slovenia. We are creating some really cool hardware solutions end-to-end for our clients. And over the past few years, I've been talking to you about some very cool aspects of our work. I've taken you up in the air with the drone mapping of LoRa signals. We've shown you the things underwater and how LoRa behaves in those difficult cases. And last year, I've taken you to high voltage. We've had some really cool Tesla calls there at the stage. This year, unfortunately, we're virtual. But I'm very happy to talk to you about that it's time now that IoT has grown up and now it's a serious thing which we can put in a lot of industrial actions. Today, I will share with you best practice and ideas on how we build new solutions and how we're creative about this. To ease our thinking, we split the IoT devices into two categories. Single-purpose solutions are one of those. We define this as being devices which have one purpose only, and that one purpose is very well defined. Let me explain that on the example of SenseStick, a product by our friends at SenseEdge, which is built to monitor microclimate environments. It's a well-defined solution which senses a known number of sensors in very well-defined use cases and environments. Because of that, it is very well built, and over the years they've really improved the whole device and the whole solution. And at the moment, it's in the large production volume. The lessons learned, however, in that process was that there was a lot of background work required to be able to build a robust and reliable solution which runs properly for all the clients. Because of that, I would like to talk about the homework today. So thinking about building IoT solutions at the moment is mostly about homework. And by that I mean dealing with the network stack, making sure the device runs properly, and building everything that allows you to take some sensor values and send them to the network server. And we would like to split this around. So we would like to spend most of the time on the actual solution, being smarter, better, and having more budget and effort for those things, and not spending as much on the homework, so to speak. However, for us here at IRNAS, where we create new devices, new concepts almost every week, we really like the solution the things industry came up with, the generic node. It's a nice end-to-end example of hardware and software integration for a single-purpose LoRaWAN device. This allows us to build things end-to-end with relatively easy process on the basis which is well debugged, well tested, and also used by a lot of other people, enabling this collaborative effort that we've seen grow with the community network of the Things Network. Our role in this process is building things on top of the design, putting our expertise of building very robust devices, very challenging sensing applications, and creating novel solutions, focusing mostly on innovation and much less on hardware. And if we all join our forces over this enables us to grow the LoRaWAN ecosystem much better and much more rapidly. Every year we like to put something on the stage, something very cool, new, and crazy. Well, this year we are virtual, but nonetheless we're keeping up the tradition. So here we're taking a rugged device, throwing it off a bridge, letting it hit the ground, but also sending a message before it hits the ground so we know what's about to happen. And then also getting reports that it survived. We take things underwater, deep underwater. And while here in Maribor we don't have very deep water, we have a test chamber which brings us almost 500 meters deep, allowing us to validate these things. Because it's winter, we need to make sure things survive at very cold temperatures. And batteries are always fun in those conditions. So we build devices and put them out to very harsh conditions and validate them, as well as do things in the lab, but that's not as fun. And lastly, there's no rugged demonstration without a gorilla, tapping onto something. But since we're not in a commercial, here's a car driving over things we've built, just to showcase about the same thing. Now that we have a broad idea of how cool solutions we can build, let's look at how we do this. Fun things aside, the focus on creating better IoT solutions is really minimizing the overhead, and software-defined solutions enable us to do this much better. Over the past year, we've been sitting at home and created this whole technology roadmap and gained the experience with all the relevant components to build robust, long-lasting, and very easily upgradable solutions which are mostly defined in software. This also allowed us to approach these projects with a no-stack methodology. Particularly LR1110 with the modem E approach integrated with the Things Industry stack allows us to create IoT devices without worrying about the stack and the LoRaWAN too much, and focusing really on the added value solutions of this. Furthermore, by building the full integration with the Nordic Semiconductor Zephyr real-time operating system, machine learning from edge pools and other components, we can create better, faster solutions very efficiently. And I also appeal you guys to look at your technology roadmap, define it well, and then stick to it, because this makes you efficient and this creates much better products than jumping from solution to solution. IoT has grown up, and here's the second category where this went. Advanced IoT edge solutions. We define these solutions as IoT devices which are multi-purpose, so doing multiple things, maybe having a primary role, but most importantly, doing much more than just collecting a sensor value and reporting it to the cloud. They interact with other devices and users alike. They particularly evolve over their lifetime. So while we may have a piece of hardware in the field, and actually we want to put it out as soon as possible, we keep evolving the logic and the brains of that device over years to come, over the lifetime, such that it becomes smarter, better, and more efficient at what it does. A key unlocking part of this is obviously machine learning, because that allows us to make complex decisions on a lot of sensor data and just send a small answer out, which means we conserve a lot of battery power, and that allows us to build more long-lasting solutions. The key question I would like to pose you all is, how much added value, how much useful things do you create per milliwatt hour of battery consumption in your IoT device? This is a good way we can think about how do we make sure most of the actions are actually useful. Let's break this down in a few cases. Instant alerting is a concept where we can look at the edge IoT device being dormant, sleeping most of the time, conserving power, energy, and spectrum, but at the same time having the ability to instantly say, hey, this important thing happened, you should really know about it. Best case to explain this is a project from our client, Isoelectro Round 1, for the electrical grid monitoring. Now, the basic function of the device is arrestor monitoring, so making sure that the component in the electrical grid is fine. So as soon as something bad happens, we want to instantly know about it. So obviously this will let us know about that particular component. But because we're monitoring the whole electrical grid at that particular point in space, as well as we're seeing all of the other effects, we can be so much smarter about what we do from this. With the use of machine learning and some very nice mathematics on the devices, we can classify events and say, hey, like these locations are important, this is happening, you should be aware of it. And this gives really the extra added value from the same piece of hardware that we had initially for the basic measuring function. The second important concept is long-term reporting. We have sensors, we have robots, we have even people, animals, everything moving in various environments. So we want to collect data over time. But also that data tends to be quite similar in a lot of the cases. So we want to really communicate only the most important parts, or really get the part which is important right away instead of waiting for a long time before we report it. So that ties into the instant reporting, but as well as looking at the case from DrainBot, an autonomous tunnel drainage maintenance system, is that we can control robots, we can put them in very difficult spaces where they will slowly traverse underground in tunnels and so forth, but immediately when they come up on something interesting, they let us know through a LoRa network, which works very nicely in such constraints and also underground environments, instead of waiting another long while before the unit ends up somewhere with mobile data coverage. A project very close to my heart is Elephant Edge, which we're working on actively with smart parks for the past months. This really allows us to create a meaningful solution full of latest and greatest technologies. But more importantly, it also showcases the interaction part between different trackers and IoT devices and the potential this unlocks. Thinking about the elephant, right? So we have a tracker where we track position, quite a standard solution. However, the interaction part allows us to do much better things. Say from the upgrade standpoint of view, we can have an upgrade node somewhere by the watering hole. When the elephant comes close by, we can upgrade it through BLE very efficiently. We can make it exchange data with other trackers or positions. We can use beacons in the field or other things from that to determine proximity and location. We can even look at the social behavior with such applications. So this is a very good example how we can collect data from the environment or have very basic low power and efficient communication, either on LoRa, on BLE, with other devices around us, and with that create a much better solution than just standalone points reporting to the cloud. As they become interactive, we gain much intelligence about our environment. So obviously we have elephants in very remote areas, and while we would like to have perfect network coverage there, that's not the case always. So let's take things to space. Let's make this possible from anywhere around the globe. We've been working with the Lacuna Space company to evolve the relay idea. So you've probably heard Thomas Telkamp talk about this in his keynote. And we're doing the implementation side of this for a real product because we see a very great need for this with many of our clients and projects in the field. Not all devices always have direct line of sight to the sky. Not all devices can necessarily say have the right antenna to be able to talk to the satellite. But also we get the additional opportunity of things aggregating data at a small, low-powered local node, which is not a gateway. And really the not a gateway approach is something I would like to keep clear in this discussion, because we can do so much more if we're at a very low power, if we are smart about making decisions on the device side. Even say the relay we have shown here, we can treat it as an edge IoT device, which we can use to make some decisions, to aggregate information from a few local nodes and make decisions then on that, what is sent immediately, what is reported as statistics over time, and also seeing what is really critical, so it should be alerted right away. So the solution we're showing here combines the network from Lacuna Space, a really nice design by Fabian Ferrero from the RF Things company, and our code running on the device, creating this relay solution, which is not only a backup channel for critical infrastructure applications, but also can do a lot more. So we're looking forward to sharing more about this over the course of the year with you. So what have we all learned today? Firstly, it's about the homework. Doing a lot of homework is nice, but it does not necessarily create cool solutions, and it does not boost the innovation. The single-purpose devices are very important for the IoT space, but let's make sure we define them as such, and when we're developing them, we focus exactly on that. On the other hand, we can let our imagination go wild with the edge IoT devices, which are low power, which are capable of a lot more, and with machine learning we keep extending them indefinitely. And by combining these two aspects and really being sure which one of the two you're building, you can be very successful in the projects. Thank you very much, and I'm looking forward to seeing you all in person next year.